Okay, now this section 6.6 is just way too cool. You're going to learn something in this section that is just really neat. And I'm going to give you a spoiler because I just think it's so cool. If you have the function f of x equals x squared minus 2x plus 1, and you want to find f of 5, you all know what to do. But wait, don't do it. Don't do it. What happens if you divide by 5 using synthetic division? Watch this. Drop the 1 and you get a 5. Add, you get 3. Multiply, and you get 16. Let's see what happens when we plug in that 5. That would be 25 minus 10 plus 1. Oh my word, 16. How cool is that? Turn to page 377 and let's let the fun begin. The first key concept is the remainder theorem, which I think is nicely summed up by the sentence above it. It says, notice that the value of f of 3 is the same as the remainder when the polynomial is divided by x minus 3, which illustrates the remainder theorem. Then it has the key concept box, where it says the same thing over again. If a polynomial p of x is divided by x minus r, the remainder is a constant, which is p of r, or it means if you take r and plug it back into p, you get the remainder, which is a constant. Then it goes down here to say this, that the dividend equals the quotient times the divisor plus the remainder, and it gives you this example. I would like to comment on this just for a minute. So if you take the dividend, which is the x squared plus 6x plus 2, and you were to divide either by x minus 4 or by x plus 10, your quotient, or the answer, would obviously be the other parenthesis group there, and in either case you would have remainder 42. And if you wanted to check your work on that division, and if you took x minus 4 and you multiplied by x plus 10 and you added 42, you should get the dividend, or the original function that you started with. And that pretty much sums up that box. Example 1 is on the same theme. They're telling you that if you want to find f of 4 in f of x, the synthetic substitution method means you just use synthetic division. You put the 4 into the box, then remember you write the coefficients of the polynomial. Now here's one tricky thing. This is the coefficient of x to the 4th. This is the coefficient of x to the 3rd. This is the coefficient of x squared. This is the coefficient of x to the 1. And this is the coefficient of x to the 0. Remember that you have to have all of those in there. That's why that 0 is in there. Also, it is based on addition. So you drop your 3, you multiply by 3 to get the 4, you add to get 10. You multiply by 4 to get 40, you add, you multiply, you add, you multiply. This is f of 4. Down in part 2, they are showing you that if you were just to plug in a 4 in your calculator, you would come up with the same answer. Very nice. Okay, go ahead and do the check your progress, pause it, and let's see how you do. All right, and your check your progress, 1A was 19, 1B is negative 6. Now if you didn't get negative 6, did you realize you needed to put a 0 where x to the 4th goes? You also need a 0 where x goes. So don't be fooled, they'll try to get you. All right, let's move along. The real-world example is based on the polynomial that they used in the beginning of the reading. And if we go back and read it, it says college, referred at the beginning of this lesson. How many U.S. college students will study abroad in 2013? And they're dividing by x minus 20. Why are they using 20? Well, if you go back and look, it says x is the number of years since 1993. So 2013 is 20 years later, so they pop 20 in there. They use long division, and they come up with this number. So they're saying it's about 340, U.S. college students studying abroad. All right, check your progress. Pause the video. All right, I hope you got 2,223.56, but at the beginning of the lesson it said that these equations were finding the number in thousands. So that means we need to multiply by 1,000 or to move our decimal point over 3 places, which means our actual number of students is as thus 2,223,560. Let's move on. Next example. Key concept, factor theorem. The binomial x minus r is a factor of the polynomial p of x if and only if p of r equals 0. Let's look at an example of what they're talking about. Let's look at f of x equals x squared minus x minus 6. If we were to factor this polynomial, we would say, oh, it's x minus 3, x plus 2. And if you multiply these two things, you get exactly x squared minus x minus 6. So if I were to take f of 3, I should get 0 because I should get 0 remainder. And if we do, we take 3 squared, which is 9, minus 3 minus 6. Sure enough, we get 0. And if I take f, just a minute, if I take f of negative 2, it also should equal 0 because it's one of the factors. If I take negative 2 squared, I get 4 minus negative 2, so that's plus 2 minus 6. Sure enough, and I get 0. Now, let's look at what if it had been x squared minus x minus 7. What if that was g of x? What should I get if I put in g of 3? I should have a remainder, right? So if I put in 3, I get 3 squared, which is 9, minus 3 minus 7, which is negative 1, which is what we would expect, because we know if it's x squared minus x minus 7, that it would be x minus 3 times x plus 2, and then I would have to add a negative 1 in order to get x squared minus x minus 7. So a nice application of this factor theorem is that if you have x to the 5th plus x to the 3rd plus 2, and that is your function, sum h of x, and you need to know if it divides evenly by x plus 1, or if x plus 1 multiplied by a bunch of other things will equal h of x, you can take f of negative 1, and that will tell you immediately whether it's a factor or whether it has a remainder. So I would take negative 1 to the 5th plus negative 1 to the 3rd plus 2, which is negative 1 plus negative 1 plus 2, which of course is 0, meaning that yes, x plus 1 is a factor of h of x, or since it's a factor, that also tells us that there is a 0 at x equals negative 1. All right, let's move along, little doggies. Example 3, using the factor theorem, is really what you will be using this theorem for the most. It says determine whether x minus 5 is a factor of x to the 3rd minus 7x squared plus 7x plus 15. Then find the remaining factors of the polynomial. So, all right, we use synthetic division to determine if it's a factor. We get the remainder 0. Yes, it is a factor. And then what does that leave us with? It leaves us with x squared minus 2x minus 3. that itself can be factored very nicely. So now we know that x to the third minus 7x squared plus 7x plus 15 equals x minus 5 times x plus 1 times x minus 3, which also, because we already know this, lets us know that this is a polynomial of degree 3 with a 0 at x equals 5, a 0 at x equals negative 1, and a 0 at x equals 3, which tells us it's crossing the x-axis 3 times and tells us a lot about the graph. So go ahead and do the check your progress. Good luck! Here is the answer to check your progress. The final answer is down here in blue. X to the third minus 7x squared plus 4x plus 12 equals the factor groups of x minus 2 multiplied by the quantity of x minus 6 multiplied by the quantity of x plus 1. Very good. Okay, I want you to try this one challenge problem before we're done here. If you've got c of x equals x to the fifth plus 2x to the fourth minus 5x to the third minus 10x squared minus 36x minus 72, and you know that c of negative 2 equals 0, find all 5 factors of this particular polynomial. You can do it. It is a challenge. Pause the video and try it. All right, just helping you along the way. If c of negative 2 is equal to 0, then you know that c of x divides evenly by x plus 2, and that x plus 2 must be one of its factors. Okay, so if you divide negative 2 out, this is what you get, and that means, since this is the remainder, this is the constant, this is x to the 1, x to the 2, x to the 3, x to the 4. That's what we have. Can you factor that? Can you factor it maybe if you let x squared be a? Then you would have a squared minus 5a minus 36. Does that factor? Of course it does. It factors into x minus 9, x plus 4. And then if we put in our x squared for a, that's a minus 9, a plus 4. And if we substitute back in x squared for a, it's really x squared minus 9, x squared plus 4. X squared minus 9 is x plus 3, x minus 3, because it's the difference of perfect squares. It is a parabola that has been moved down 9. This is a parabola that's been moved up 4, meaning that we have imaginary roots on this one. So that's x plus 2i, x minus 2i, and here are 4 of the factor groups for this 5-degree polynomial. What is our last one? Of course, it's the one that we started with, x plus 2. And so this is the full factored form of c of x. I hope that you understood the challenge and did well with it. Good luck. I will see you soon. Bye-bye. That's all I've got for section 6.6.